Okay, beautiful peoples, let's make a battery box. Today I'm going to make a laser cut battery box using Autodesk's 123D design. And I know what you're thinking. It's 2025. Why are we still using this program? It's too old. I'm just familiar with it. I have Fusion. I've worked with Inventor a few times. But when I need to make a battery box, this is what I come back to. So I start with a square, and we're going to guess about what our battery box might be, but we can change it later. And I'm going to go with 220 by 610 millimeters. And we'll zoom out and then drop a cylinder at 46 millimeters to be our battery. Now, this is the great part I love about this program, because you can check the measurements between the edges and make sure we're within our margins, and we want to be around 2 millimeters. I'm not too crucial on it because there's a little bit of play in the size of box we're going to make, but 2 millimeters is around what you want because that's the bus bar, not limit, but about midpoint. So I can do 2.5 and I can do 1.5 and it still works, but shooting for 2 is good. And it also makes it more symmetrical to keep 2 on the edges if I'm going to keep 2 in between the batteries. So now that that's been measured, checked, and fixed, we're going to use our pattern tool to select the cylinder and then select the leading edge. And this will stack the batteries out and however many we want. And this is where there's a little bit of a guess and check. I've tried to do the math to figure out the spacing, and I came up with 508, tried it, and it didn't work. Then I tried 512.2, and eventually I found out that it was 530.2, which was the perfect spacing to get 2 millimeters in between the battery cells. And as you can see, 2 millimeters. Perfect between them all. So now we've got that 13 set, I believe it is. No, it's a 12 set. So we're making 12 by 5. We're going to make a 60 cell battery total, 30S times 2. So what we'll do is we'll put the 12 that go together on one side with 12 next to it and then 6 in the middle. And let me show you that diagram here. As you can see, I've got my positives on the outside and then my 2 negatives located next to each other in the middle, with the routing of the battery for the first 30 and the other 30 kind of separated and kind of configured. It might be confusing, but the black bars are the ones that are on the front face and the red bars are the ones on the rear face. It'll be more obvious when we actually assemble the battery later. But let's get back into the designing portion of it. So I want to stack these batteries, obviously staggered pattern, with 12 in each of the 5 rows. And as well as keeping up with the 2 millimeter spacing between them all. Now this is where I don't get exactly 2 millimeters on every single one, because the catty corner staggered pattern, I don't know if it allows that or how to get that close, but I'm thankful that I don't have to, because I have a little bit of play with the bus bars. And I'm not going to stress on that kind of thing too much. So there we have our first 24 down, and I can copy paste the whole 24 out. Whoops, I got 0.6 off, so let me move that. And I just, I move it, shift it a little bit here and there. It's pretty easy to shift it a millimeter this way, that way, and then recheck. And yeah, this is kind of why I like the program. It's kind of why people don't like the program, because it's moving models around. This is not parametric modeling. Fusion's kind of halfway in between. Some of the times you can get a parametric modeling out of it, but I like this. This is like bricks to me. So as you see, we've got our spacing pretty fair there. Well, I think maybe one more move. Of course, it always jumps 5. Let's do 1. Eventually, here, I will get it. Let's see. Yeah, 1.5. That's a little much. 1.3. So I think 0.5 away from now would probably do it correct. Let's see. Oh, and I moved it down by mistake earlier. So let's move that back. And let's do just 1. Probably should do 0.5. Let's try 1. No, 1's too much. I already know. Yeah. I need to do 0.5. Actually, I'd probably live with 2.2 and 2.2. Yeah, I like that. That'll work for the bus bars. Oh, yep. See, I moved it too tall. Move it back down. You gotta watch this. Grabbing the wrong arrow sometimes, but thankfully things you can go backwards on pretty easy too. So now that we've got the first 24 completely laid out, I'm going to copy all of those and move them over, and we'll have 48. And of course, after we have 48, we'll have our 60, and we copy one more final row all the way over. Now, this is the more challenging part, I think. This is the easy, lay out your cells, figure out how it's going to be. You don't always have to do the diagram where you figure out front and back, but this is also the first parallel pack I'm building into one battery, so I wanted to make sure that there is a way to hook all of them up, ending on one side, ending on the top side. And thankfully there is, because the cells are an even number. If I run an odd cell count, I will always end up with a positive side on the left and a negative side on the right. That's the nature of the beast. So here you can see I've got my spacing figured out. It was, I think, 83, as you saw I typed in. 2 millimeters, 2 millimeters, 2.2, 2.2. The next step in the process is going to be, first let me get these 12 over. And I'm going to actually trim this down and see if we're going to live with our 605 or 610. What did we start with? I think I'm going to go with 605 because I think I see a little bit of space there. I always like to keep whole numbers for the box actual size because, as you see later, I'll have to do some math for the tab width, and using whole numbers just makes it a lot easier to start with. I could have made this 612 or 614 spaced out to have 2 millimeters from the edge, but like I said, whole numbers are your friend. Oh, I didn't say that. Well, I'm saying that now. Whole numbers are your friend. It's really what you got to do. And I think this will go down to 605. We've got, can obviously eyeball a little bit of space on each end. I want to keep the distance a little bit narrow on that direction because it goes in between the wheels. So I don't want it to be on the front tire and I don't want to be on the rear tire. I need to be right in the middle, and keeping this as narrow as possible is good. I do have a box I think currently at 625, and it's a little close. So losing 15 would be good for me. So now that we've got this kind of finalized in our size, we're going to jump into our web browser, and we're going to go to makeabox.io. Yep. And this is where we put in our width, our height, and now for our depth, or actually how tall they're going to be, which is our height, is going to be 165 plus 10, so that I can have a little bit of space and put some TPU 3D printed spacers in there to keep them from arcing out or scratching if I used metal case in the future with this design, which I may do. I don't know yet. I may just redesign a whole box when I'm making them out of metal, but this one's going to be wood or acrylic or a combination of the two. So after this, we will export, and that's it. Part 1 done. Now part 2. Are you ready? Opening up the file that we just saved, and we're going to open it up with Inkscape. So I'm going to go here, and you can see how the layout is at the top corner. But when we open up Inkscape, for some reason you can't see it. I don't know how to make it visible. Whatever. It doesn't even matter. You save as SVG. As you can see, I've already saved it once at the top there, so I have to overwrite it. And it transfers it into an SVG. And Inkscape's job is done. That's all we need it for. Back into Autodesk, we take an SVG and we import it as a solid. And this is where our computer comes to a crawl. And I mean a crawl. It will slow down. Even my fast desktop with the GeForce 3070 slows down until I turn the thing upside down and delete the 2D graphic. So that's always the first thing I do. You can see I've got my end plates, my top plates, my bottom plates, so on and so forth. But yeah, it's very, very laggy. You'll see as I rotate it. It's bad. So if we can get all the way there. All right, now select the bottom, hit delete, and everything's good again. Now we're high speed. So I can delete 3 of these, resize them, and move them as you see here. Now this is what I was talking about, keeping your whole numbers. It's important because, see the little tabs? Each one of those is 6.3. So to resize these correctly, and I don't know why it loses the size. I've tried it several different ways, and it always seems to make things bigger and transfer it. We're going to know it's 620 by our depth. Oh, excuse me, 605. 605 plus 6.3 plus 6.3. And that is 200. Oh, we're doing the width first. That's right. Sorry. 232.6. Right? That's 220 plus 12.6. So 232.6. Everything is going to be our original width plus 12.6. And so, yep, that's, do the math. Yeah, that's right. 220 plus 12.6. Now, we'll take another one. 605 or 175. I guess we'll do the same piece. We'll do our 605 is going to become 617.6. And it's tiny compared to all these other ones. But yeah, let's do these other ones. We'll shrink them down, and it'll start to make a lot of sense here in a second. Right now, these things would be, let's see, 5 meters. That's a pretty big panel. I'd like to cut that size panel, but that's probably as big as my shop. No, it's bigger than my shop. Excuse me. So, as you see, we took the 175, added 12 to it, which is 187.6. And we'll move those closer to our cells. You see those things way, way down there? That is our cells that we designed earlier. And we're about to put them in this box. Well, we're going to attempt to. I don't think I'm actually going to cover all of the failures I went through. It's a really long video of the same thing about 15 times over, where I try to move a piece, and when I grab it, for some reason it has grouped everything in the object, or everything in the workspace, as part of its group, and if you ungroup it, it crashes. If you move it, it crashes. If you do anything with that piece other than delete it, it crashes. So eventually I delete it and I start over. But to get zoomed in, when you've had them so big, you have to hit home, and it brings them kind of back into their natural centered environment, where our center is right there in the middle offset screen, center of the screen. Excuse me. So, what next? Well, we gotta, first I'm going to save a copy. In fact, I might even save 2 or 3 copies of this, because this program is bad about crashing. So, let's get into it. I'll go ahead and tell you, this is a voiceover. And this program crashes about 15 times. I opened it up. One of my saves, either save, didn't matter. I think that black background it showed initially was kind of like a bad omen or something. But I can select and resize. Whoops, see, crashed. If I select all and do anything, it will crash. Actually, it's the tiny one on the other side, the little end cap. When I touch it and try to do an action, it crashes. And so I can resize this one. Okay, cool. We're going good. 6.3. We can resize this one. Okay. Let's do that. Let's, oh, no. I ungrouped it. Crashed. Try again. I tried again many times. I'm not going to bore you. That's another 10 minutes, 15 minutes of footage of me grabbing one of these, trying to do something, trying to ungroup it, trying to change the size, trying to figure out what it is that's causing the problem. See, I can move those two. They're good to move. Later on, I ungrouped them successfully, and I can deal with everything but that little smaller one. But the smaller one, for whatever reason, just every time I touched it, I tried to ungroup it, I tried to resize it, it would crash. See, that ungrouping worked, but I didn't save. When I try to resize here, it's going to say something funny. Oh, no, it doesn't say anything funny, it just goes back to desktop. So after this final crash, I'm going to cut all the crashed footage, and we'll skip to the final edge. So here is the final time. I got all the cells arranged in this pattern, but I couldn't do anything else. So I deleted them, and I started over with a SVG to a solid, and of course flipping it upside down, deleting the 2D graphic on the bottom. Yeah, I did it all the way over again because 15 minutes of it crashing. You know, there's a reason they don't use this program anymore. There's a reason they went on to Fusion. It had some bugs. They never solved them. They said, you know what, we're not even going to bother. So I moved a little bit quicker this time, moving my cells down and or not my cells down, my panels down to their appropriate size. What was that? 605 plus 12.3, 12.6. Yeah, because 6.3 times 2 is 12.6. Easy math, right? It's easy math. I think the problem is there's 3 dimensions in remembering when you use double or when you use single, and of course there's the cell width, the cell spacing. I don't write any of this down, guys. I'm gonna be honest. It's written down in this program. So when I know it, I bring the program on a USB or I email it to myself and I look it up. I bring my laptop along for the ride. Anyways, I've got these mostly down to their size. I've mentioned earlier that I made this battery box for a Lexus. I've done also a Prius 70 cell. I used 5 lithium iron phosphate batteries in a row to make about 20 volts or 18.5 volts. And it's amazing. In my Prius, I ran out of gas, and check engine light came on, engine wouldn't start, but I was doing 50 miles an hour down the road, so I decided not to stop and just let it keep going. And I could give it a little bit of throttle and maintain 50 miles an hour for about 2.5 miles till my exit. Then I came to a stop and sped back up to about 30 miles an hour and cruised at 30, 35 on just electric power, about 4 or 5 miles to a gas station, which is absolutely incredible in my opinion. These lithium batteries I'm going to be putting in the go-kart are the exact same cells that I've used in the Prius. Actually, these are bigger cells. These are 25 amp hour cells. Once again, hit home once you get these guys close together, and it will bring them all back into their focal point. That's what we want. Focal point. That's the right word. And you may even have to do it 2 or 3 times, bringing them close together, because even here is too zoomed out. And just hit home. So, now we're starting over, kinda, except for some reason they won't be grouped together, those cells in the middle. I also know when I go to move my box, don't try to grab all 60 cells on this quite slow laptop and move them onto the box, rather move the box underneath them. But in the meantime, you can quickly observe how I smash these out into 6.3 panels. 6.3, if you don't know, is about the thickness of my acrylic panels, but thicker than the wood. It should be a 1/4 inch, but 1/4 inch wood doesn't actually come out to 1/4 inch wood now, does it? It's more like 5.5. But it's okay, because they look great. You won't really even see that little bitty tab difference. I would have to grab the leading edge tab and move it in, and grabbing each one of those tabs individually is quite hard. I don't want to do that. So as you can see that I space it 175 plus 6.3, which is 181, Yep, yep. And then I group those two together. I'll drag this 605 plus 6.3, which is 611.3. And then I will group those two together so they stay as one piece, which I check here and nope, it didn't grab. So I'll regroup it. Bam. Now it is grouped. Now I take that group and I will rotate it after I make this group. This one's 226.3 because that is the width for all 60 cells. One of the most fascinating transformations of this whole process is going from seeing it in digital to holding the batteries in your cells in your hands and sliding the cells into place. It's just like, you know, I went from this was nothing, this was pixels, to something. So, let's assemble a battery box. We will take these two and rotate them. Let's see, which one's our top and which one's our bottom? First we're going to assign them. I don't know why I'm doing it this way. I got to rotate them. I'm forgetting to rotate them. Yes, grab. No. Grab and rotate. Silly. I've used this program a lot for 10 years in 3D printing on my sailboat. And still I don't remember where the grab to rotate versus the grab to resize is. I get them swapped. But there you go. Grab. I almost never try to rotate it into 90 degrees. I just type it 90. It's much faster. And this also needs to be rotated 90 degrees. But on plane, not on the Y or X, but on the Z. Oh, and on the X. So now we can assemble our battery box and then check it over. Make sure there's no overhangs to make sure we got all our values correct. Let's zoom in and see. Whoops. Well, you can't just grab the top plate. You got to kind of select them all. And I think the problem is I got to hit the move button after that. When I hit grab again, just reselects just the top. Anyways, we can look it over pretty well from this. Yep, clean edges. Looks good to me. Let's maybe save it. That sounds like a good idea. So this thing crashes. Now we'll take this battery box and slide it underneath the cells, because the sooner we get these 60 cells off screen, the faster this whole program is going to move. It does not render multiple objects very well on slow speed computers. This is just a basic laptop. I can't say it's basic. It's a Core i7 9th gen, I think, 16 gigs of RAM. But 3D programming is obviously, something heavy. So we're going to space this and get this as close as we can by dropping it down and making it so the cells poke out the top just a little bit. Normally I actually put the cells as their full length, which is 165 or thereabouts, but this time I didn't. And I figured a different way of making this by just removing the top and then moving it, you'll see. I remove the cells from the top and then make the top the middle and then use the bottom as the top. The first thing we're going to do here is get these things in position. I had them in position with the other piece before, but that positioning piece didn't have a puzzle on it. I think I've actually done this with the centered. The problem is when you select the cells, it slows the laptop down. I do not want to touch selecting them. I want to just touch one at a time if I have to, and check and make sure my tolerances are close enough so that I'm not overgapping. I got 7 over there. Actually, I make a mistake, and instead of touching 7 there, we're looking good. But 7 there, 6.7. So, nope, that does not look good. That is too small. We need to increase that. So 1.3 over there, and 1.7 over there. Probably move it 2 or 3. Two, 3. Yeah, that looks good. So now we'll remeasure 7. Well, that's what we had over there. But do I have the same thing over there now? Always double check. Oh, shit. I just lost it. I can see now. Maybe I clicked the wrong edge. I better move it. Yeah, well, 5.5, that's not right. What are we... Oh, I'm on the top edge of the cylinder. That's my mistake. I need to select the actual edge of the plate. Alright. Let's figure out how we do that. And just the whole wall, not the edge. I want the whole wall, not the top edge. Dang you. Yes, the wall. There you go, 1.4. If we got 7 and now 1.4 down here, obviously 3 is too much. So undo. What did we have? We actually had 3. With 3 and 1.5 on the other end is a total of 4.5. So split that in the middle, and we need about 2.2 on each end. So if this is, what was it, 1.3, we need to move it just 1. 1.5, let's move it 1. So move the whole box over 1. Got to select all the panels so they stay together. And select the direction, but it's going to go to 10. We got to change that to 1. Alright, now we're happy centered. Now we can speed the computer up and get rid of these stinking cylinders. Now, instead of selecting all of them individually, I'm going to lay this thing down flat and highlight the very, very, very top edge without touching the box. Boom. And that grabs all my holes. And when I say holes, I mean holes. Ta-da! So, obviously this is not the top. As I said before, we're going to save once again. We got to a very healthy point where the laptop goes fast again and we can move through these stages without it crashing. So, in fact, what I'm going to do from here is I'm not going to reassemble the box. It looks good. I'm going to move all of these pieces away from each other. Oh wait, I do have to do one step. I'm going to space these two 100 millimeters apart so they hold the cells at 100 millimeters apart inside the battery. And then I need to drop these two into the battery to cut their support holes out of the walls of the battery box. So we'll copy them, we'll group them, and then we'll center them with our handy-dandy alignment tool. It's just right there. I guess I'll have to, let me back out. Let me do this again. Yeah, now we got them all highlighted. Now go to align. Now center, center, center. Obviously, when you're doing the align, it uses a lot of power from the card too. Whoops, that one didn't have a buddy, so it didn't get centered on the ends. It got actually centered in the middle. We'll just move it out of the way. There's our box. There's our top. We'll make 2 tops and we'll put it on the bottom. Box, 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 box. Dang, that looks big. It's going to go in the go-kart? Oof. I don't like it. No, I don't like it anymore. It's going to be too big and too heavy. 60-pound battery. Yikes. But you know what? 60 kilowatts. I put 26 of these cells together and got 25.5. So I would say that 60 of these together will be good for 60. I'm probably going to limit it to 50, make them a little more healthier on the lifespan of them. Anyways, back to the design. As you see, I've copied and then removed by using the subtract tool on each of these walls, or each of these pairs of walls, so that when I now move this panel away, it will have its holes cut out for the insert piece that holds the cells, like that. So that one's good. We'll move it away, and then we'll pull off our SVGs. SVGs, you say? Yes, we are back to SVGs. That's what our Corel Draw or Lightburn software will use to cut with the laser. So you select the plane. Actually, you select export to SVG first. The important thing to note here is that I move all of these box pieces away from each other, because if they're on the same plane as the side pieces, it'll pick up the lines for the side pieces and give you a bad draw. And the laser can't cut with that. That looks good to me. Even though it doesn't have the holes all the way through, it has the lines where they need to be. That's where the laser will cut, and the laser will cut all the way through. I'm not worried about that. So, export time. We'll save once more. It's safe. Alright, export. We're going to go to export 2D SVG. And it just picks out the normal plane. So you got to pick out the new one. Pick that wall. And this is going to be our 60S battery box. We're going to put it in our go-kart files just to make sure it's with everything else. Oh, not 26S, 60S. Yeah. And then, of course, that is the sidewall. We'll call it front side. And save. Now we'll do the top or the middle. We'll do another one. This top piece is our cell holder, the insert. I like to do these in acrylic because with all the curves you can shine light through and it looks pretty cool. You'll see that later. Alright, we have that one saved. Now I'll grab this end piece or side piece. We'll grab the end. We already have a side, that's right. So, cell middle, end, and then we need a top or a bottom. So, export to SVG, at the top plane. As you can see, the red line is the trace that it's going to make. I'd like to thank you for watching this video and follow me for more content as we will take these files and put them into our laser cutter, cut the battery box out, and then assemble the battery. And then there'll be a video of me actually getting to test the thing on the track. Really, really soon. Keep going. Thanks, guys.